question concerns the sizing of the water ground, also known as the grounding electrode conductor connected to a metallic water pipe, when a driven ground rod is also present. The answer is #4 American wire gauge, as per National Electrical Code Section 250.56 ATWA. Now let's delve deeper into the specifics. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations to ensure safety and prevent hazards like electrical shock and fire. Article 250 within the NEC is dedicated to grounding and bonding. Grounding electrode system requirements cover the purpose and methods for establishing a connection to the earth. This connection is crucial for providing a low impedance path for fault current, which helps protective devices like circuit breakers operate quickly to clear the fault. This rapid clearing minimizes the duration of potentially dangerous voltage on equipment and reduces the risk of electrical shock. The grounding electrode system typically involves multiple grounding electrodes bonded together to form a more effective connection to the earth. Common grounding electrodes include metallic water pipes, ground rods, ground rings, and concrete encased electrodes, often referred to as UFO grounds. The metallic water pipe is often the primary grounding electrode. The NEC requires that the metallic water pipe be supplemented by an additional electrode, such as a ground rod, ground ring, or concrete encased electrode. This redundancy ensures that the grounding system remains effective even if one of the electrodes becomes compromised. Section 250.56 ATWA specifically addresses the size of the grounding electrode conductor for a water pipe electrode. The section states that where a supplemental electrode is used and the grounding electrode conductor is connected to a ground rod, ground ring, or concrete encased electrode, that portion of the conductor connected to the ground rod, ground ring, or concrete encased electrode shall not be required to be larger than #6 American wire gauge copper or #4 American wire gauge aluminum. However, the portion of the grounding electrode conductor that runs to the metallic water pipe must still comply with Table 250.66, which generally requires a larger size conductor based on the size of the service entrance conductors. The key point is that the reduction in size to #6 American wire gauge copper or #4 American wire gauge aluminum only applies to the portion of the grounding electrode conductor connected to the supplemental electrode, not the portion connected to the metallic water pipe. In the scenario where you have a driven ground rod and a metallic water pipe within 5 feet of the point of entrance to the dwelling, the water pipe must be bonded to the grounding electrode conductor. According to NEC 250.56 ATWA, while the conductor connected to the ground rod can be as small as #6 American wire gauge copper, the conductor running to the water pipe needs to be sized based on the size of your service entrance conductors as per Table 250.66. Let's consider some examples. Firstly, if you have a 200 amp service, Table 250.66 typically requires a minimum #4 American wire gauge copper conductor for the grounding electrode conductor. Therefore, the portion of the conductor running to the water pipe must be at least #4 American wire gauge copper, even though the portion running to the ground rod can be #6 American wire gauge copper. Secondly, if your service is 100 amps, Table 250.66 would typically require a minimum #8 American wire gauge copper conductor. However, keep in mind that the requirement of #4 American wire gauge for the water pipe connection supersedes this in certain situations, as explained below. If the water pipe is the only grounding electrode available, it must be sized per Table 250.66 for the service entrance conductor size. The supplemental electrode, such as the ground rod, is what allows the reduction in size for that portion of the grounding electrode conductor. To reiterate, the primary reason for these rules is safety. A properly sized grounding electrode conductor ensures that in the event of a fault, sufficient current can flow back to the source to trip the overcurrent protection device, such as a circuit breaker, quickly. This rapid clearing of the fault minimizes the risk of electrical shock and fire. Another consideration is the material of the grounding electrode conductor. Copper is the most common material due to its excellent conductivity and corrosion resistance. Aluminum is also permitted, but it must be sized larger than copper to achieve the same level of conductivity. When using aluminum, be sure to use connectors and terminations that are rated for use with aluminum conductors. Furthermore, the grounding electrode conductor must be continuous, meaning it should not have any splices or joints within the run. If a splice is unavoidable, it must be made using a method approved for grounding conductors, such as irreversible compression connectors or exothermic welding. The location of the grounding electrodes is also important. Ground rods should be driven deep enough to make good contact with the earth, and they should be located where the soil is moist. Metallic water pipe should be bonded to the grounding electrode conductor as close as possible to the point where they enter the building, and any insulating sections or unions in the water pipe must be jumpered with a bonding conductor. When installing grounding systems, always follow the manufacturer's instructions for the grounding electrodes and connectors. Use appropriate tools and techniques to ensure that the connections are secure and reliable. Also, remember to inspect the grounding system periodically to ensure that it is in good condition and that all connections are tight and free from corrosion. The NEC is updated every 3 years, so it's important to stay up to date with the latest requirements. Changes to the code can impact the sizing and installation of grounding electrode conductors, so it's essential to consult the latest edition of the NEC for the most accurate information. In summary, when dealing with a driven ground rod and a water pipe within 5 feet of the entrance to a dwelling, the grounding electrode conductor connected to the water pipe must be sized according to Table 250.66, but not smaller than #4 American wire gauge copper. The conductor connected to the ground rod can be sized as small as #6 American wire gauge copper. Always refer to the latest edition of the NEC and consult with a qualified electrician to ensure that your grounding system complies with all applicable requirements. Correct grounding is not just about meeting code, it's about protecting lives and property from electrical hazards. Remember that the grounding system is a critical component of any electrical installation, and it should be designed and installed with care and attention to detail. Ignoring or improperly implementing grounding requirements can have serious consequences, including electrical shock, fire, and equipment damage. Therefore, always prioritize safety and follow the NEC guidelines when working with electrical systems. In addition to the NEC, local codes and regulations may also have specific requirements for grounding systems. Be sure to check with your local electrical inspector to determine if there are any additional requirements in your area. Some jurisdictions may require more stringent grounding measures than what is specified in the NEC. Furthermore, the type of soil in your area can affect the effectiveness of grounding electrodes. Soil with high moisture content and low resistivity is generally more conducive to grounding than dry, sandy soil. If you have concerns about the soil conditions in your area, you may need to use additional grounding electrodes or soil enhancement techniques to improve the effectiveness of your grounding system. Also, remember that grounding is not the same as bonding. Grounding connects electrical systems to the earth, while bonding connects metallic parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety, and they work together to minimize the risk of electrical shock and fire. In conclusion, the sizing and installation of grounding electrode conductors can be complex, but it's important to understand the requirements to ensure a safe and compliant electrical system. Always refer to the latest edition of the NEC, consult with a qualified electrician, and follow all applicable local codes and regulations. By taking these steps, you can help protect yourself, your family, and your property from the dangers of electricity. The information provided is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before working on any electrical system. Electrical work can be dangerous, and it should only be performed by trained and qualified individuals. Remember to always turn off the power at the breaker before working on any electrical circuits. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, please hire a qualified electrician to do the work for you. Your safety is paramount. The National Electrical Code is a comprehensive document, and it contains many other requirements related to grounding and bonding. It is essential to familiarize yourself with the entire Article 250 of the NEC to ensure that your electrical system complies with all applicable requirements. Keep in mind that the NEC is a minimum standard, and some situations may require more stringent grounding measures to ensure safety. Always exercise caution and use your best judgment when working with electricity. With proper planning, design, and installation, you can create a safe and reliable electrical system that will provide years of trouble-free service.